In this video, we will work 5 examples on how to assign oxidation numbers to each atom. These are the rules we follow to assign oxidation numbers. We must follow these rules in order. You will need to know these rules as they are not provided on the exam. As you practice the oxidation numbers, keep these rules close by and refer to them frequently, and it will not be long before you will have them memorized. Here's our first example with calcium sulfide. We begin with Rule 1. This is not an element. Rule 2. Yes, we do have an ionic compound with a metal and a nonmetal. Calcium is the cation and the sulfide ion is the anion. Referring to the periodic table, we know that the charge of the calcium to be 2+, so our oxidation number is +2. The charge of the sulfide ion is 2-, so the oxidation number is -2. And we're done. The perchlorate polyatomic ion is the next example. Beginning again with Rule 1, this is not an element. This is not a monatomic ion. It is a polyatomic ion. Yes, we do have oxygen. The oxidation number for oxygen is -2. We do not have hydrogen. We do not have fluorine. Here we will need to use Rule 6 as we do not know the oxidation number for chlorine. It will not be -1 since chlorine is not a monatomic ion in this case. Chlorine is part of a polyatomic ion. In this example, we add all of the oxidation numbers for each atom. We have 4 oxygen atoms, so we need to add them all with each having a -2 oxidation number. The total sum of all of the oxidation numbers is the charge of the polyatomic ion, which is a -1. We then solve for chlorine. You can also do this same thing with an algebraic equation. We find that the oxidation number of chlorine in this case is +7. Here is our next example. We again work our way down the list. We do not have an element. We do not have an ionic compound with monatomic ions. Here our compound is molecular and not ionic. We do not have oxygen. We do have hydrogen, and we assign hydrogen a +1 oxidation number. We do not have fluorine, and we will need to find the oxidation number of nitrogen with Rule 6. This oxidation number of nitrogen will not be -3, since nitrogen is not a monatomic ion in this case. Since we have a neutral compound, the sum of all the oxidation numbers will be 0. Notice that there are 2 nitrogen atoms. We can also use the algebraic equation to solve for nitrogen. The oxidation number for each nitrogen is -2. In our next example, we have sodium sulfite. It is not an element. It is an ionic compound with the sodium ion as the monatomic ion. The sulfite ion is a polyatomic ion. We know the charge of the sodium ion is 1+, so the oxidation number is +1 for each sodium atom. We also have oxygen, and the oxidation number is -2. We do not have hydrogen. We do not have fluorine. We will again need to use Rule 6. In this case, the oxidation numbers add up to be 0. The compound is ionic, but it is considered to be neutral since we have both cations and anions present. Again, we can use an algebraic equation to solve this. The missing oxidation number is +4. This is our last example with the phosphate polyatomic ion. It is not an element. It is not a monatomic ion. It does have hydrogen. We do not have hydrogen. We do not have fluorine, and we will need to add up all of the oxidation numbers. This time they add up to the charge of -3. Solving for X, we find the oxidation number of phosphorus is +5.